Hello everybody, here's a rectangle that is given by its diagonal that is 13, 13 units long, and it has also 7 units long segment over here at certain angle to the diagonal, and we're supposed to figure out how long is this red line, and I will do the construction using software called GeoGebra. When you start, you just type geogebra.org to your browser and you should get this screen, and we select calculators, go to the first option, and now we can draw anything we like. I will start with the diagonal, so I go to segment and then I go somewhere here, and I need 13 units long segment. You can move that segment to origin to be sure it's really 13 units long, and then I will create point at a distance of 5 units, and then we have this segment split to two segment of 5 units long and 8 units long. It will be convenient to also place here one more point at the center, and you will see later how I will use it. So we choose this first option, start from there, and we need to go 7 units. So it's somewhere here. You can check if it's really 7 units. So we see the radius, or the center of the circle is at 5, that's good, and 7 squared, it's 49, that's good too. I want one more, so from D, from the center, and that one will go to here. Now, the radius of the second circle is 6.5 units. So that's what we see here. The center is at 6.5. That is good because it's in the middle of our diagonal, and 6.5 squared, that's the radius, is this number. So all looks good. Now what we have here is this intersection. That's nice. So we pick the segment, can go between A and this point here, and then also to the point B. Now, due to the fact that we use the circle here from the center, we know that there will be 90 degrees over here that is needed to get the correct rectangle. We are using Thales Theorem here, so please explore this on your own. But we also have guaranteed that the distance from point C is 7. That's due to the circle C with radius 7 units. So now we can double check that by using another segment over here. Right click, settings, and then we can place here the value. And then you see we really have the correct distance from this location for the point C to F. Now, don't think I need the circles anymore, except, well, I do need, well, we need the last vertex of the rectangle somewhere here. So what I create is line from F through the center, and that creates point over here that again will be the last vertex of our our rectangle. So we connect A and G, G and B. Now to clean up this, we go back to here to our intersection, the circles. It starts to look good. We need those points at this moment just to keep this as clean as possible. I hope I don't need any more the coordinates. So now it looks all much better. See the B there still. You can highlight the whole thing like this. And then remove the labels. It's maybe too many. So here I like to see this number 7. That's good. Maybe here we want to see so the value of 13. That's good too. And then we need to create some additional things. So I guess we want to see that from this vertex to the center we get 5 units. So in that intersection and here we can again place the value. So that's good too. And then finally we can figure out what is the distance from this vertex to this location. So let's create one segment from there to the center. And now we will get the length and the answer to our question. So again, we'll remove the K, J, the just the settings again. I will make it red, so thicker than the others. This is our answers, and the value. Okay, the value is not a simple number. When you do careful calculations and derivation of this problem, you can find out that this number is exactly square root of 40. So let me write it down. Text. I'll place it somewhere. So we will write square root of 40. That one can bring closer. So here we have this distance, and I think what is also interesting is to see the sizes of the sides of the rectangle. So for example, this one, we get value, also very non-trivial number. That number is square root of 104. So let's type it in. So one more time. 104. be another one. Let's just get ready for the next one. That's square root of 65. So that one did work. So let me put it here. That would be this side. Let me finish that one. So here we have non-trivial result as well. It's easy to see that it is a little bit bigger than 8. 64, square root of 64 would be 8, and we have a little bit more. And what about this thing? I don't know why it is doing so. So let me start one. That's better. So now place it over here. And we have pretty much everything done. We can try one more thing to get the angle over here. It seems like it is 90 degrees. And when you do derivation of this whole procedure using linear algebra or similarities of the triangles that are in this picture, we can actually prove that it is 90 degrees. So let me see if I get it right over here. Okay, so that didn't work. So I probably need my points. So I'll put them back just like quickly. So that one more over here at the bottom. Now it should stick with those. So we go with those 3. We see that angle truly is exactly 90 degrees. I'll go back to just take the points away. And this looks pretty good. So that looks, can move it to the center. Thank you for watching, and try to do this construction by hand. That's fun too, and see how accurate you can get, or try to recreate using GeoGebra. Thank you, and see you soon.